Thank you, Kia.
All right.
Auntie's leg. I'm telling.
I thought it was close, didn't I? You got my calculator and another calculator.
No, she's probably gonna pop it with a pass.
All right, so I need everybody paying attention. And we are going to do probably the 2 problems that are worth the most points on the exam. 2 of the multi-part free response questions. So we're going to go through them right now. So here we go. So I am, on my exam review sheet, I'm specifically going to do number 59. But this is a problem where you are given an equation of a trig function. And this one is tough because this is what we started in December. And then we had Christmas and I don't know, here we go. So this is a long time ago. So, but here's what I want you to think about. We are going to draw a picture of this. All right, we're going to draw a picture of it. We're going to list the amplitude, the period, the phase shift, the vertical shift, the domain, and the range. I'm sorry, pay attention. Now, some of this is super simple, and some of it's a little more complicated. Your job is to get as much right on the test as you can, right? So we're not going to sweat the really, really hard stuff, but there are some points that you absolutely should get. For example, you should be able to look at this equation and tell me that the amplitude is 3. When I draw this equation, which I know what a sine curve looks like, a sine curve looks like this. You need to know that. You should know that. That's what a sine curve looks like. And it's going to go up 3 and down 3. Now the period, that's a little bit tricky, but we've talked about it before. You need to remember that the period is supposed to be 360. 2 pi, 360. If you put a number here, it divides the period.
Oh yeah, I remember.
You remember that? Yeah. So there's no number here though. So if there's no number there, the period just stays 360.
180, something.
Now, if there had been a 2 here, then it would be 360 divided by 2. Okay? If there'd been a 1/2 here, it'd be 360 divided by 1/2, which is 360 times 2, right? 720. But there's nothing there, so it's just 360 divided by 1, which is 360. Phase shift and vertical shift, that's how the graph has been moved sideways and up and down. We spent enough time on this with our BFFs, you should know this. If I put a number inside the parentheses like that and add or subtract inside the parentheses, that moves my curve sideways, right? Which way does this one go, right or left? It goes right. And pi over 2 would be 90, 180 divided by 2. So this thing is going right 90. Now what does that 2 right there mean? Up 2. That's my vertical shift. Now, sines and cosines, and that's all you're going to have to graph. You're going to have to graph either a sine or a cosine. Sines and cosines, all these rules are the same for them. The picture's different, but all the rules are the same. The domain of the sine and cosine is always all real numbers. That's the domain of the sine and cosine. These pictures, even though we only draw one hill and one valley, the reality is they go on forever and ever. The domain is all real numbers. Now we're going to come back to the range in a second, because the range is the up and downness of the curve. Now, if we look at the curve with an amplitude of 3, that means it's going up 3 and down 3, right? So its range would be -3 to 3. That would be the range. But stop, that's not the range of ours, because what did we do to it?
Went up twice.
It went up 2. So that means it started here, but everything went up 2. So the actual range will be -1 and 5, because the low point went up 2 and the high point went up 2, because of the vertical shift, right?
It's cold in here.
So these things, if you really study, you can do this. You can fill these in if you really study. The amplitude is always that number. The period is always 360 divided by this number. Inside the parentheses is your horizontal shift. Outside the parentheses is your vertical shift. The domain is always all real numbers. And then the range depends on the amplitude and the vertical shift. Everybody in the room is going to get partial credit on the graph, because even if you don't know how to graph this, you know the shape. It's a sine curve. So you're just going to slap a sine curve on there. Now, I'm going to draw it correctly so I get full credit. The normal sine curve starts right here. Remember original sin, origin sine? But this one has been shifted right 90. So it is going to be drawn over here. It starts over here at 90. It doesn't start at the origin because it got shifted 90 inside the parentheses. Now the period is 360 degrees. So from here,
wrong on that one.
no. So the period is 360 degrees.
I thought you were supposed to go up 2 when we started.
Well, I haven't done that yet. I'm going to do that in a minute.
Oh.
First, I want to get these labels. You're right. I have not done my vertical shift yet. I'm going to do that in a minute. But it's easier for me, Monty, to do my labels before I move it.
Okay,
so
sorry.
I'm going to do the labels and then I'll move it. You are right. Oh, I need to know where I'm going to end. So I need you to use your common sense. Where do you think I'm going to end? Don't say 360 because I got a 90 head start. So if I got a 90 head start, this is going to be what?
Three.
450. That's exactly right. I'm going to end up at 450 because here to here is 360 degrees. But if I got a 90-degree head start, then don't I have to go 90 more past 360? Which puts me at 450. Any idea how I'd find that label? Add them, somebody said it, add them and divide by 2. How do I find this label? Add them and divide by 2. And how do I find this one? Add them and divide by 2. So there are the labels. And then, as Monty said, this is Ford, if you want to get all the points for this problem, and this problem is mega points here. If you want to get all the points, you got to raise it up 2. So every point comes up 2. And the blue curve is your final answer. So you took the sine curve that you always draw and you shifted it 90 degrees to the right and 2 units up. Okay? That's a huge problem. So let's review one more time. Filling this in is going to be easy. We're not going to mess these up. The amplitude is that number. The period is 360 divided by that number, right? Phase shift comes from the parentheses. vertical shift comes from the outside number. Domain is always all reals. And the range is a combination of how high the original one went and the amount it was shifted. Now, the good news is there's one more huge problem. But that's it. There's just one more. So that would be problem 61. And problem 61 says we're given a couple points. Whoops. And now there are a ton of questions. So the first question, and they are in exactly this order on the exam. The first question says, what are the components of vector AB? So you're going from here to here. What are the coordinates of that vector?
2.
No.
4.
4.
2.
Nope.
Oh, negative.
Negative 2. The
Okay.
coordinates of the vector are 4, negative 2. You do not have to be a genius to figure that out. We're going from negative 1 to 3. 4 steps. We're going from 4 back to 2, negative 2. Those are the coordinates of the vector. Okay, so we got 2 points. First thing we're going to do is find the coordinates of the vector from A to B. Now, second question is this. What does that mean?
Okay, so that's your answer, and then you root it. Well, you root 4 plus negative 2 and square root it, right?
Well, I'm going to be square rooting it. But what do I square root? I have to square these numbers.
Yeah.
So the magnitude, this means magnitude, is square the first, square the second, add them up, and take the square root. To find the magnitude, you square the first, square the second, add them up, and take the square root. Right? And then reduce your radical if you have to. Everybody understand how I got 20?
Yes, ma'am.
All right, then I square root it. That's the magnitude. Now the next problem is find the unit vector.
No, on this paper.
Anybody remember how to find the unit vector?
Isn't it that you do that next denominator? Like find the denominator and then put the, oh, never mind.
Well, you're on the right track. You have everything you need. To find the unit vector, you take your original vector, which was 4, negative 2, and you divide by the magnitude. So if I'm taking notes, I'm writing down that to find a unit vector, this is a guaranteed test question. This is on the exam. And it's so easy because you've already got everything you need right here. To find a unit vector, you take your original coordinates and divide them by the magnitude. Now, that does simplify. So if we want to get full credit, we'll simplify it. But that is the setup for it right there. Take the 2 coordinates and divide it by 2 root 5. Now, in terms of simplifying, see this 2 and this 4? They're going to cancel. So that's 2 over root 5. And then that 2 and that 2 are going to cancel. So that's negative 1 over root 5. So I've got that far by just canceling out those extra 2's in the problem.
As your denominator.
I'm not done, Kia, you're right. Now I've got radicals in the bottom. So I'll multiply the top and bottom. Quit sighing heavily, Kevin. It's not that bad. I'm going to rationalize, and when I rationalize, I move the radical to the top and remove the radical in the bottom. So it's 2 root 5 over 5 and negative root 5 over 5. That is the answer to the question. Okay? Now, some of you that were here during Flex, this is a little redundant, but you know what? Practice makes perfect, so we're just going to do it again. Let's recap. This is a test question worth a ton of points. Step 1, find the vector. So go from here to here and here to here. There it is. Step 2, find the magnitude. This means magnitude. How do we find the magnitude? We square it, add them up, and take the square root. Then we got to find a unit vector. How do we find a unit vector? We take the answer to number 1 and divide them by the answer to number 2, and then do whatever we need to do. Now the next question says, find a vector in the same direction that has a length of 4. Now, this is super simple. Here is your unit vector. Guys, the definition of unit vector is its magnitude is 1. Its magnitude is 1. So the length of this vector is 1. I want a vector whose magnitude is 4. This one's 1. So think of it as being this long. How do I make it this long? What do I need to do? Times it by 4. So I'm just going to take this vector right here, and I'm going to multiply it by 4. So that would be 8 root 5 over 5, and negative 4 root 5 over 5. What if I wanted the length of it to be 3? What would I do? What if I wanted, instead of being 4, what if I wanted it to be 3? I times it by 3, right? So whatever length you want it to be, take your unit vector and times it by that number. Then we got another one. Now it says, write the vector equation for the line. Now, for this problem, I actually have written this on the answer blank. So this will be written there. That's the vector equation of a line. But I'm going to have all this written out right here. Does anybody remember, you have everything you need up here on the board. Does anybody remember what goes where in any of those parentheses? The first one always gets an X and a Y. Anybody from Flex this morning remember what goes in the other ones? The original point, and there's 2 of them, right? We had 2 original points, so you can use whichever one you want. So you're going to put one of the original points in here, so I'll put 3, 2. One of the original points goes in the first parentheses. Now, what goes in the second parentheses?
Effect point. I'm just kidding. 8 root 5 something.
What are the answers? Not the answers, but
The vector. So in that parentheses goes 4, negative 2.
then you cover up the Y's and
Now that's the answer, all right? So what goes in the first parentheses? X, Y. What goes in this one? Original point. Either one. What goes in this one? The vector that you figured out.
Oh, and then X equals
And then the last
3
question is,
plus
what are
14.
the parametric equations?
X equals
Which is when you take this thing and break it up. So Monty, what does X equal?
3 plus 4t.
Yep,
And then Y equals 2 minus 2t.
perfect.
I mean 2 minus
No,
t.
you're right. 2 minus 2t. No, you were right. It's 2 minus 2t. So how did Monty do that? X is the first part of every parentheses, right? So she just made an equation out of the first part. X equals 3 plus 4t. Then she made an equation out of the second part. Y equals 2 minus 2t. There's like a bazillion points right there on the board. None of it's hard. You just have to remember what to do. So that's why you got to practice. Okay? All right, so those are the 2 mega problems. on the board. Let's go back and look at some of the other ones. Now, so we'll go back to the beginning, because I haven't done, this is our first time with this review sheet, right? We haven't done anything. So we can go back to the beginning. When you guys get rich and famous, you can buy me some new erasers. Let's go back to the beginning. And number one, y equals 3 sine 2 x minus pi over 3 plus 1. This is problem number 1 on the review sheet. This is a horrific problem, but it doesn't say sketch. It doesn't say find anything except the period. Okay? Now we just talked about that because it's part of one of the big free response. This is a multiple choice question. How do we find the period? It's 360 divided by that number, right? So the period is going to be 360 divided by 2, which is 180. Now, multiple choice, right? What could be, if 180 is not there, could there be any other number there that would still be okay? What's the same as 180?
Oh, that thing.
Pi.
Yeah.
Isn't pi the same as 180?
Yep.
So if one of the answer choices is 180, that's great. But if 180 is not there, but pi is, that's okay too, because isn't 180 the same as pi?
It is, Mrs. Ford.
It is. All right. Now, next one. 3 sine 2x. It says describe the range. Now that means if you were to graph this thing, here's your sine curve. If you were to graph it, how high up and down does it go? It goes up and down 3. Someone said it. Thank you, Malcolm. It goes up and down 3. Does this one have a vertical shift of any kind? No. So that would be it, right? So what's the range? -3 to 3. Yep. When you write your interval, it's always the littlest to biggest. So that's the range. Number 5. I'm doing all the odds because tomorrow night I'm going to do the evens. So that entire test will be one big video. This one's kind of piecemeal depending on the different periods.
I'm coming tomorrow, Miss Ford.
Monty, nothing makes me happier.
I won't be there tomorrow.
No, at 5 o'clock.
Okay.
Tonight.
Now,
You are a
this is
dedicated
problem
teacher,
5,
Miss Ford. You know that?
and it says we want to find v dot u.
Yes. I know.
She didn't even answer because she's so dedicated.
Did you hear me, Miss Ford?
No, I didn't.
I said you are a dedicated teacher. Do you know that?
I try to be.
You really care about
Humble.
your students.
You know, you got me that good grade on that final last time.
V dot u. Here we go. Anybody remember how to do a dot product? This is called the dot product. Anybody? Well, okay, so what'd you say? Okay, Joseph is right on target. He says you multiply x times x, and you multiply y times y, and then what do we do with those? Well, how do we put them together? Add them. Somebody said add them, and that's right. So you multiply x times x, y times y, and you add them together. Now listen, you guys, that is so simple. But you have to remember the rule, and you're only going to remember it if you practice it. X times x, y times y, so the answer is 7. Answer is 7. Number 7, find the vertex.
Nothing is ever that funny.
Find the vertex. This should be a no-brainer for you. What's the vertex? Bingo, very good, but back there, Mr. Almost 100% on the test, he says the vertex is -1, 3.
Miss,
Now, what's going to happen to kids that aren't paying attention?
they're gonna get F.
They're going to turn that around, right?
Right.
Make sure you put x first. X first. X always goes first.
Miss Ford.
All right,
I don't
one
need it.
more. We have time for one more.
No.
What?
I thought we get out of 110.
Oh, me?
No. I mean, yeah. We don't never get out at 115.
Oh, actually, it is 110. Sorry about that.
Yeah.
Okay. I will.
So committed to intelligence. Get out.
Never do that.
Here.
Oh,
Teaches us.
if you have my calculator, and there are 6 of you with my calculators.